How to master unit conversions for gas properties. Imagine trying to cook a new recipe without knowing how much a cup or a teaspoon is in grams. It would be confusing, right? The same idea applies to calculating gas properties in thermodynamics. If your units are off, your calculations could be way off too. So, mastering unit conversions is like having a universal language for gases. It helps you switch between different measurement systems smoothly. Whether you're working with pressure in pascals or atmospheres, volume in liters or cubic meters, or temperature in Kelvin or Celsius, knowing how to convert makes all the difference. Start by familiarizing yourself with the key properties and their common units. Pressure might be in pascals, atmospheres, or bars. Volume could be in cubic meters, liters, or cubic feet. Temperature must be in Kelvin for thermodynamic calculations, but sometimes you'll see Celsius or Fahrenheit. Specific heat capacities are often in kilojoules per kilogram Kelvin or joules per mole Kelvin. The gas constant, which appears in the ideal gas law, varies depending on the unit system, so understanding how to convert it is essential. Next, understand the ideal gas law, which relates pressure, volume, temperature, and the amount of gas. When working with moles, it uses the universal gas constant. When using mass, you switch to the specific gas constant. Knowing how to convert between molar and mass-based units is key to accurate calculations. Always keep your units consistent throughout your calculations. For example, if you convert pressure from atmospheres to pascals, multiply by 101,325. To convert Celsius to Kelvin, add to 173.15. This step is simple but vital to avoid errors. Use conversion factors carefully. Dimensional analysis helps here. For example, 1 liter equals 0.1 cubic meters, and 1 atmosphere equals 101,325 pascals. Multiplying by these factors ensures units cancel out correctly, leaving you with the desired unit. When working with the gas constant, remember it depends on the system. To convert the universal gas constant from kilojoules per kilomole Kelvin to joules per mole Kelvin, divide by 1,000. If you know the molar mass of a gas, you can find the specific gas constant by dividing the universal gas constant by the molar mass in kilograms per kilomole. This helps switch between molar and mass-based calculations easily. Practice is your best friend here. Use thermodynamic property tables for gases, which list values like enthalpy, entropy, and specific heats in standard units. Knowing how to interpret and convert these values ensures your calculations stay accurate. For example, if a table gives specific heat in kilojoules per kilogram Kelvin but your calculation needs joules per kilogram Kelvin, just multiply by 1,000. Let's say you're calculating the enthalpy change in a gas flow. You might need to convert velocities from meters per second to kinetic energy units in joules per kilogram. Doing this correctly ensures energy balances are right. Remember, temperature scales matter too. Always convert Celsius or Fahrenheit to Kelvin before plugging values into thermodynamic equations. In the end, mastering unit conversions for gas properties is about understanding the properties involved, knowing the common units, and applying systematic methods like dimensional analysis. This skill makes calculating gas behavior in thermodynamic systems straightforward and accurate. It's a fundamental step that helps you see the bigger picture clearly and work confidently with gases in any cycle or process.